Hi, welcome to a new section of control systems. In today's class, we are going to see some examples related to block reduction technique. In our previous class, we have seen the basic rules which are involved with block reduction. So following the rules, we'll start solving the first problem. We need to find out the transfer function C of S by R of S, and this is the block which is being given in figure 1. So you know that R of S is input and C of S is treated as output, and G1, G2, G3 are generally called as gain blocks. And you have the summing points, which is shown by the circle with cross as plus and minus. These are regarded as summing points. You have a block with negative feedback, and you have a negative unity feedback. So we'll follow the basic block reduction rules in order to solve the given block. So first, combining the blocks in parallel, you can see G2 and G3 are in parallel. So that can be removed with the help of G2 plus G3. And again, you have a feedback path. So you can eliminate the feedback path like this with the help of G2 plus G3 by 1 plus h of G2 plus G3. Now that can be replaced instead of this block, and you have a combined series block of G1 with the latest resultant. So this is how you're going to get the reduction of this particular value for this particular block to this block. Now you have a final unity feedback, so that can be eliminated with the help of the same formula, that is C of S by R of S is equal to G of S by 1 plus G of S H of S. So I'm substituting the value of G of S, which is given in this forward path gain, that is a combination of G1 of G2 plus G3 by 1 plus H of G2 plus G3. So that is taken in the numerator. 1 plus, you have the value of unity feedback, so I'm taking the value of G of S, that is open loop transfer function, as it is over here. So with proper LCM and cancelling out the like terms in the numerator and denominator, you're going to get the transfer function value as G1 of G2 plus G3 by 1 plus H of G2 plus G3 plus G1 G2 plus G1 G3. I hope you understood this example. Now we can easily obtain the transfer function of C of S by R of S for the block diagram shown in figure 2. Here you see what is the alteration done with the previous problem. You can see another feedback path, that is H1 in a negative way. It is taken as a third loop, so that can be removed with the help of the block reduction what we followed for the example 1. So combining blocks in parallel, you have this blocks in parallel, so replaced by G2 plus G3. Then you can eliminate the feedback path, so I'm eliminating the feedback path like this, that is G2 plus G3 by 1 plus H2 of G2 plus G3. Then you have the series combination of G1 with this particular reduction. So combining blocks in series, I'm going to get the value as G1 of G2 plus G3 by 1 plus H2 of G2 plus G3. And finally, you have the unity feedback. So that can be eliminated with the help of G1 of G2 plus G3 by 1 plus H2 of G2 plus G3 plus G1 G2 plus G1 G3. Now, this value what we obtained, I can directly substitute over here in the place of G, that is G of S, and H is nothing but H1. So I'm employing this formula, that is a standard formula. I'm going to get the transfer function of C of S by R of S, which is equal to G1 G2 plus G1 G3 whole divided by 1 plus H2 G2 H2 G3 plus G1 G2 plus G1 G3 plus G1 G2 H1 plus G1 G3 H1. I hope you understood this block reduction technique. Please comment in the chat box if at all you are getting any another answer or different answer. Let us go with another example. Now, unlike in the previous two examples, here directly some variables and numericals are given. So we need to find out the transfer function for this. Again, you can see you have three loops. First feedback loop is with 2, another feedback loop is with 1, and third feedback is with S. All are the negative feedbacks. Okay, we will follow the first approach, that is combining the blocks in parallel, which is S plus 100 by S plus 100, and eliminating the feedback path, that you are going to get the value here as S plus 100 by 1 plus 2 of S plus 100. Now this can be replaced with this particular direction, and you have the overall gain will be, that is open loop transform gain will be 1 by S square of S plus 100 divided by 1 plus 2 of S plus 100. Okay. Now let us eliminate the unity feedback loop. So for this, you're going to get the reduce transfer function over the value over this particular reduction as s plus 100 by s square of 1 plus 2 of s plus 100 close two brackets plus s plus 100. Now finally you have the feedback path with s. So I'm reading the block with feedback. I'm going to get the block in this fashion. Now this block can be easily reduced with the help of the formula of G of s by 1 plus g of s h of s. So that is done over here. So C of s by R of s value will be s plus 100 whole divided by s square of 1 plus 2 of s plus 100 close double brackets plus s plus 100 plus s square plus 100s. I hope you understood how we got this final value of C of s by R of s. Further, you can uh, uh, take the common terms and take the powers of s terms. So you're going to get the transfer function as s plus 100 by 2s cube plus 202 s square plus 101s plus 100. So this is the overall transfer function for the given problem. Now this is an interesting problem which is shown in example 4, where you have um, blocks G1, G2, G3 and G4 and the feedback paths are H1 and H2. So first what I'm going to do, I'm moving the takeoff point before G2. So this takeoff point is taken before G2. So this is how it looks like. So you can see this takeoff point is taken from this left right of G2 to the left of G2, and this block H1 will be multiplied with G2. That is an important reduction technique of the takeoff point. Once we are done with this, you can see you have G4 in parallel with series combination of G2 and G3. So for this, you are going to get the value as G2, G3 multiplied with, sorry, the multiplication of G2 and G3 with summing of G4. So this can be done with this approach. You can see these blocks are eliminated, G2, G3 plus G4, and the rest of the blocks are kept as it is. Now what we can do, I'm taking this summing point and I'm placing it before G1 as shown in figure 4b. This is what is done. So with this, what we can do, summing point is change. When you're changing the summing point, that particular summing point block, which is nothing but H2, gets divided by G1. This is another important reduction technique of summing point moving from right to left, that is H2 divided by G1. This is an important point over here. Then you can interchange these two blocks such that G1 had the feedback of H1 G2, and you can have the overall uh, parameter which is shown in this figure like this, that can be eliminated with the help of negative feedback H2 by G1. Now you can see after interchanging the summing points, this is the block which I'm going to get. I'll take out this block with the parameter of G1 by 1 plus H1 G1 G2, right? And you have the series combination with G2 G3 plus G4. So that can be done by combining the blocks in series in this fashion. I hope you understood how we have framed this. Now finally what we are going to do, just replacing the series combination with the formula which is shown over here on the step 5, and then eliminating it with the feedback of H2 by G1 with a negative value. So that can be removed by eliminating the feedback path in figure 4e like this. Taking this one as the upper numerator as G and the denominator H value as H2 by G1, and again G value as G1 of G2 plus G2 G3 plus G4 divided by 1 plus H1 G1 G2. So this is the replacement of this entire block. So this reduction will give you the result as G1 of G2 G3 plus G4 divided by 1 plus H1 G1 G2 plus G2 G3 H2 plus G4 H2. Fine. Now this is the final block before unity feedback what we got here. So from figure 4f, again apply the rule of transfer function. What we have, that is C of s by R of s is equal to G of s by 1 plus G of s h of s. So that is I'm going to do over here. So treating h of s value as 1, I'm going to get this particular numerator by denominator value as G1 of G2 G3 plus G4 whole divided by 1 plus H1 G1 G2 plus G2 G3 H2 plus G4 H2 plus G1 G2 G3 plus G1 G4. It's a standard problem which you can see many textbooks. Example, you can go with the control systems by Nagurkhani. You can see this particular example. Also, the previous examples you can relate it to different textbook problems what we have selected, and we got the transfer functions for all the blocks which are given under block reduction. So try for example for which is shown in example 5. You have this particular block, and the transfer function you're supposed to get the answer as C of s by R of s is equal to this numerator by this denominator. And comment in the chat box whether you got the same answer or not. If not, in the next class we are going to see this particular problem to be solved with block reduction technique, also with the help of another approach called signal flow graph. So in the next class we are going to see the basics of signal flow graph, and we'll apply the signal flow graph to this particular problem, and we'll check whether we are going to get the same answer under block reduction or under signal flow graph. So I hope you like this particular class. Please share among your friends and subscribe to this channel and press bell icon for the future notifications. Thank you.